A plane flying with tailwind flew 300 kilometers in 2 hours. Against the wind, it took 3 hours to travel the same distance. Find the speed, in kilometers per hour, of the plane and the wind. So before we start this problem, we need to define our variables. We're going to have two different variables, one for the speed of the plane and one for the speed of the wind. So let's just use our usual variables of x and y. We'll define x as let x equals the speed of the plane. And then we'll define y as let y equals the speed of the wind. Now that we have both variables of x and y, we can start by creating our equations. But first, let's just remind ourselves what tailwind means. Tailwind means that the wind and the speed of the plane are both going in the same direction. So that means the tailwind is going to help the plane move faster. Because this question deals with speed, time, and distance, it would be helpful to use the equation of v, velocity, multiplied by time equals our total distance. So, using this equation, let's first start with our first sentence. A plane flying with a tailwind flew 300 kilometers in 2 hours. So let's first start with our v, which is the speed. So because we have our plane, we're going to have the speed of the plane plus the speed of the wind, because the tailwind is helping the speed of the plane. So we're going to have x plus y, all as our speed, and we need to multiply that by t, which is our time. Well, our time is given to be 2 hours, so we'll multiply the speed by 2 to give us our total distance d of 300 kilometers. So now we have our first equation of x plus y multiplied by 2 gives us 300. Instead of distributing this 2 to everything inside the brackets, let's just make it easy on ourselves and divide both sides by 2. So we're left with x plus y equals 300 divided by 2, which is 150. So now that we have our first equation, let's look at our second equation. Our second sentence says, against the wind, it took 3 hours to travel the same distance. So instead of the wind going in the same direction as the plane, the wind is going opposite. So that means we're still going to have the speed of our plane, but the wind is going to decrease the speed of the plane. So we're going to subtract the speed of the wind, y. All of that is our v, and we're going to multiply that by t. Our time is now given to be 3 hours, so we'll multiply that by 3 to give us our distance to be the same distance, which is 300 kilometers. So again, instead of distributing this 3, we'll just divide both sides by 3. And we're left with x minus y equals 300 divided by 3, which is 100. So now we have our two equations. X plus y equals 150, and x minus y equals 100. In this problem, we can either use substitution or elimination. But as we can see, both of our variables x have the same coefficient in both equations. So that means it'd be quite easy to use elimination. So let's use elimination. We'll first use our first equation of x plus y equals 150 and subtract that by our second equation, x minus y equals 100. Starting with our left column, we have x minus x to give us 0, and y minus negative y, well, minus a negative is positive, so we have positive y plus y to give us plus 2y. And then we have 150 minus 100 to give us 50. So moving this over, we have 2y equals 50. To solve for y, we'll divide both sides by 2, and we get y equals 50 divided by 2, which is 25. So we've solved for y, but now we need to solve for x. So to solve for x, we can use either one of our equations. We can use x plus y equals 150, or we can use x minus y equals 100. It doesn't matter. In this video, I'll use x minus y equals 100. So wherever we see a y, we will replace it with a 25. So we have x minus 25 equals 100. Then to solve for x, I'll add 25 to both sides, and we're left with x equals 100 plus 25, which is 125. So now we have our y variable and our x variable. So x was the speed of the plane, so we solved that x is 125 and our units are kilometers per hour. And y, which is the speed of the wind, was 25 kilometers per hour.